Hey guys, how you doing? Welcome to Venus Neuron, your go-to resource for medical school success. Now in this video, we're going to talk about secondary bones. If you're wondering then what was primary bones, you gotta go watch the first video about it, which is about the primary bones and Westberg theory and so on, and a lot of information about it. You just need to go and watch that video first. But you're good to go with this video. Now let's get started. A secondary bond, also known as intermolecular bond, is a type of weak bond that forms between molecules or atoms, but it's not as strong as primary bonds, such as covalent bonds or ionic bonds or metallic bonds. Unlike primary bonds, which involve the sharing or transfers of electrons, secondary bonds arise from electrostatic interactions between molecular dipoles, temporary charges, or induced dipoles. You might be wondering, what's a dipole? A dipole refers to a separation of positive and negative charges within a molecule or system. It arises when there is an uneven distribution of electron density, causing one part of the molecule to become slightly negative and the other part to become slightly positive. The polarization of charges creates what is called a dipole moment. In simple terms, a dipole is a molecule or part of a molecule where one side is electron rich or negatively charged and the other side is electron deficient or positively charged. You might have also heard about dipole moment, which is a measure of the magnitude of the dipole represented by the symbol of mu. It is calculated as the product of charge and distance between the charges. The dipole moment is a vector quantity, meaning it has both magnitude, which is the size of the dipole, and direction, pointing from the positive end to the negative end of the molecule. Now, getting back to intermolecular forces. They are secondary bonds between molecules, hence the name intermolecular, between molecules. They are much weaker than the intramolecular forces, which means within the molecule, of attraction. But they are important because they determine the physical properties of molecules like their boiling point, melting point, density, and enthalpies of fusion and vaporization. We're going to cover them in the next video, don't worry about them. Now, what are different types of intermolecular forces? We have dipole-dipole interactions, hydrogen bonding, London dispersion forces, and van der Waals forces. So, what are dipole-dipole interactions? It is a type of van der Waals force, and these forces occur when the partially positively charged part of a molecule interacts with the partially negative charged part of the neighboring molecule. Polar covalent bonds form dipole-dipole with neighboring molecules. It's the strongest intermolecular force. You can see it here. The other one is hydrogen bonding. This is a kind of dipole-dipole interaction that occurs specifically between hydrogen atom bonded to either oxygen, nitrogen, or fluorine atom. Well, if you watched the first video, you know what does this mean. They are highly electronegative. Hydrogen bonding is a relatively strong force of attraction between molecules, and considerably energy is required to break those bonds. High boiling point and melting point can be observed here, such as in water. Look at the picture. This one is the hydrogen bonding, and that one is the intramolecular polar covalent bonding. Okay, so intramolecular here, hydrogen bonding or intermolecular here. Lastly, we have London dispersion force. It goes under the category of van der Waals forces. These are the weakest of the intermolecular forces and exist between all types of molecules, whether ionic or covalent, polar or nonpolar. The more electrons, the stronger the London dispersion forces are. Bromide has more electrons than chlorine, so we have higher boiling point. And it's somehow a temporal bond. You can see it here. This one is an intermolecular nonpolar covalent bonding, but this one is a London dispersion force. So let me tell you like a short explanation on what is a van der Waals force. It is a general term used to define the attraction of intermolecular forces between molecules. There are two kinds of van der Waals forces, weak London dispersion forces and stronger dipole-dipole forces. And you know what they are now. That was all for this video. In the next video, we're going to cover laws of dilute solutions, going through vapor pressure, boiling point elevation of solution, freezing point depression of solutions, what each of them means, and then we're going to cover osmosis and so on. Now, that was it. And if you have any recommendations for topics or if you have any questions related to it, let me know in the comment section. Don't forget to like if this video helped you and subscribe for a lot more videos in chemistry, in biochemistry, medical chemistry, and also other related topic to med school. And as always, stay curious, keep learning, and I'll see you in the next video.